All right, hello class, this is my synthesis example. And with all synthesis problems, you're going to want to follow like the same sort of methodology. So to begin, you want to identify what is going on in the starting material and in the end product. So we have this 1-chlorocyclobutane and we're changing it into this 4-oxobutanoic acid. And so the first thing you want to do is count the carbons. So 1, 2, 3, 4 carbons in your starting material, and then 1, 2, 3, 4 carbons in your end product. So that means that we don't have to lengthen the carbon chain, so that is good. Another thing you want to notice is this chlorine here, this chloride. You don't see that at all in the end product, so that should right away tell you that there's going to be some sort of elimination. And another thing to notice is these functional groups here. These are carboxylic acids, so that's going to come into play later on as we get closer. And so let's begin. So you want to treat this with E2 mechanism conditions. So you need a strong base and a strong nucleophile. In this case, let's just do NaOH. So, as we know, there's no stereochemistry, but it would have to be anti-periplanar. But in this case, it doesn't really apply here. So let's just move along. And so, if we want to draw the mechanism, this will take this hydrogen. The hydrogen's electrons will form the double bond here. And as we know, the leaving group will leave. And so we are left with this product here, cyclobutene. And so this double bond is our vehicle to a whole different and various mechanisms. However, another thing to note is that we have a ring and we want to change. So that automatically should be an alert to cleave this double bond. So oxidative cleavage is the name here. And the carboxylic acids, this is where you want to refer back to. So as we know, permanganate will form, let's just write it, 4H3O. This is very important to note here. So KMNO4 cleaves alkenes to form ketones and carboxylic acids. Oops, carboxylic acids. And since it's a ring, it'll add to both sides symmetrically. So that will lead us to our product.